my talk is called Magical Thinking from Astrology to Code Reviews. You'll understand why. That's me, that's my wife, she painted me like that, with a dog. I love dogs, I love cats. I used to live in Georgia and I saved at least 50 dogs directly and sent enough money to save more than 50 other dogs.
Yeah.
Thank you. It's my LinkedIn here, yeah, if you wish to. Thank you, sir. I'm also a developer, a QA, developer advocate, which means that I work with communities, an engineering manager, and I started doing JavaScript in 2001, so it's 23 years, and it was Internet Explorer 5.5, sad times. Yeah, it was fun. And I love teaching people. I've been mentoring people since 2015, I think, and one of my mentees was a junior developer then, now he is a CTO, and I'm proud of my mentees. I want to start this talk from this story of Ignaz Semmelweis. He was called the savior of mothers. In 1836, the mortality rate of women giving birth with the help of surgeons was 18%. So every one out of 5 women died on the surgical table. Semmelweis thought that surgeons who performed in anatomical theater, they were cutting cadavers, cutting dead bodies to show their students how to perform surgical operations. He thought that they had parts of dead bodies, cadaver particles, under their nails and on their hands. And Semmelweis thought that these cadaver particles were infected the blood of women. So he hypothesized that something caused infection, and that is why women died. He thought that if he applies some substance, it was carbonated lime, I think, something like that, which washes the smell of the dead body particles away, he thought that maybe the infection will go away. And in his clinics, he reduced the mortality rate from 18% to 2%. So even though his theory was wrong, because it is germs which produce infection, not cadaver particles per se, but still he managed, through empiricism, he managed to prove that if we simply start washing hands before helping women give birth, they will die much less. He started asking the surgical community to wash their hands, and he was quite angry about it. He was writing letters to famous surgeons saying that you're killing women, you're just simply killing women by your arrogance and ignorance. You don't want to wash your hands, and that is why your patients die. His story was quite sad. He was mocked for it, and he was put in mental asylum in a mental facility. And surgeons who were mocking him, they tried to prove that he was mentally sick. And the guards in this mental facility, they beat him a lot, and he died. He died from streptococcus infection, the same infection that he was fighting for the women. And these 3 brilliant surgeons, they were actually quite brilliant, those surgeons. They were developing new practices of surgical practices, but they said that doctors are gentlemen. I think it was Meigs who said that doctors are gentlemen, and gentlemen's hands are always clean. So you, Semmelweis, you, Ignaz, you can't be right. Our hands are always clean. And yeah, he died because of that. And I think that the reason why...
The problem is actually on the premise, because they're saying doctors are gentlemen, and if you go back to the 1800s,
yeah,
that's a trade.
Yes, yeah.
So they're not gentlemen.
Yes.
They're actually working for a living, right?
You're very right, yes. And I believe that it wasn't simply because they were bad people that they acted in a certain way. I think they were subject to quite widespread biases, like status quo bias. So we are good surgeons, we practice a lot, we save women's lives, because they did save women's lives, it's just they weren't as efficient as possible. And some Ignaz, some Hungarian doctor says that we need to change the way how we operate. Who is he to lecture us? Like, or we should retain our status quo. And also, they supported each other in these ideas. So it's called a groupthink bias, where you, with your fellow practitioners, fellow professionals, talk about something, you are more likely to support each other than someone from the outside questioning your practices. And I would say that the phrase "gentlemen's hands are clean" are not far away from belief in astrology, simply because the fact that someone is a gentleman or perceives himself a gentleman doesn't have anything to do with the state of his hands. His hands can be dirty or clean. Simply very similar with astrology. And I once had this mistake when I was an engineering manager, and one of my members of the team, he approached me. Yeah, this is me, I was young. And he approached me and he said that he read a research paper on pair programming. And he suggested to try it out. He said, I've read that it allows for better knowledge sharing, lesser lead times, so we start and then we finish earlier. And I was saying, of course not, we're not going to be paying twice the salary for the development. Like one feature, two developers sitting together on this feature, why would I pay twice? He argued that in that research paper he read that pair programming makes the whole process cheaper. Because if we focus on the speed of delivery, as Edward will be talking about, we want to become as fast as possible to be able to validate our product hypothesis faster, and to get better results faster. But I simply said no. I simply said, I am the engineering manager, I am supposed to be managing the process of our team, and so you go and work how I told you. It was absolutely the same mistake as those three gentlemen did. And in science and engineering, time usually shows who's right. 20 years past Semmelweis' death, Louis Pasteur and Koch, they found the germs theory, and they actually saw the germs. And they found the theory, so basically they found out that Semmelweis wasn't right, but they found out that his empirical approach was right. They found different substance to wash the hands to destroy the germs, but anyway, they proved that he was right. Pretty much the same. My talk is called Astrology and Code Review, is focused on astrology and code reviews. And with code reviews, the industry is getting there as well. Two QR codes, one to my article, one to someone else, I can't remember who, where we review the theory behind code review and the data. I review the data that I had, comparing code review with other ways of working. But can we allow to wait so long? So during those 20 years after Semmelweis was dead, nobody washed their hands. And can you imagine how many women died? So there was a good proposition, a good proposal to start doing something to improve the situation with some proven data that he had in his clinic. And in our engineering practices and QA practices, I believe that we have only a few competitive advantages over other companies. First, of course, it's the last here, but it's the first one. It's proper product work. If the product is bad, no one's gonna buy it regardless how well we build it. But if the product is right, then we need to focus on quality and speed, because quality and speed are defined by our process efficiency. How fast can we build things? The whole agile movement emerged for us to be able to iterate faster. And by iterate, I mean that we bring something to the customer, they see if they like it or not, because before that we only have a hypothesis if they're gonna like it. They see if they like it or not. We iterate again and again. So process efficiency is what makes us faster and better than the competitors. And also quality is one of the advantages that we have. There are multiple research papers proving that up to 70% of users will switch to a competitive product if it is perceived as a higher quality product, simply perceived. They don't have a way to look at our code. They don't have, they can't run tests that we run. They can't do code reviews that we do. They only care if the tool is good or not. I switched to MacBook ages ago and I still love it. Simply because when I have to touch Windows computers, I just feel they aren't as good as I want them to be.
Controversy. Not to carry on.
Okay, yeah. And probably you've heard the proverb, cogito ergo sum, I think therefore I am. But it's the short version of the longer proverb, dubito ergo cogito ergo sum, I doubt, therefore I think, and therefore I am. And I believe that we should doubt, that we should question our ways of working, our ways of operating. And if someone, as on the picture I showed you where a junior developer came to me with pair programming proposal, if someone comes up and says, or if you read it somewhere, a research paper saying that maybe in your context, pair programming would be better, or code review would be better, some idea which sound interesting, I think you should try it. I think that if we focus on getting more competitive in the market, we should question our ways of work and we should try other solutions. But how do we do that? This is the base of empiricism, the empirical approach. We formulate the problem and we formulate how we can judge if the problem is solved. I call it definition of solved. Is it solved or not? And how well is it solved? Then we generate multiple possible solutions, come up with a list of criteria to compare those solutions, choose the solution, experiment, get data, and review solution later. So, also I need to make sure, you need to make sure that if you are coming up with some solutions to some problem, you invite as many people who know programming, testing, engineering as possible, while still retaining the management of the whole thing. If you invite 100 people to brainstorming session, it won't work. But invite various people, invite testers, invite product managers, invite developers, because diversity of opinion matters. You know, if you did anyone run a brainstorming session?
Yeah, I can
Yeah.
also put in GitHub and you can actually.
Okay, so if you run brainstorming session, you know that more options is usually better. That's the whole point. And also criteria are better weighed. For example, I, as an engineering manager in one of the teams, didn't know how much conflict was generated by code review. So there were two seniors on the team, and whenever they had to review each other's code, they were arguing a lot. I didn't know about that, that was my fault, but if we were to review code review process against pair programming, against anything else, together they might have brought these criteria as like conflict generation criteria to the table. So let's try to run the empirical process for the code review. First step is to formulate the problem and the definition of how the problem is solved. I've seen, in my experience, two problems that code reviews are usually brought in to solve. First is lack of code and product areas knowledge, so that if I'm writing the code and Masha doesn't write this code, she should write some other code. She doesn't know how I approached some problem in the code, how I wrote it, and so then when she is to write some code for this module, it will take her a very long time. And second problem that code reviews are supposed to be solving is bad code on production. I call it bad code, but simply people say we care about quality, that is why we're bringing in code reviews. We want others, so if I write the code, I want Masha to have a look at the code, to find defects, to find suboptimal places, to find something which can be bad. And so how can we formulate if the problem is solved? We can't just, I think we can't just introduce a practice just because we want to introduce the practice. I think we introduce any practice to solve the problem. So if these are the two problems, how can we reason about the fact if it's solved or not? First problem, lack of code knowledge, is that developers don't get stuck. So I write the code for the module, Masha does the code review for the module. My hypothesis is that when she is to write code for that module, she doesn't get stuck. She can easily jump in and work on it. For the second problem, bad code in production, how I can measure or reason about how it's solved by code review, is that I have 0 or close to 0 defects leaked to QA, to production, to somewhere else. And what other solutions can we find for those two problems, lack of code knowledge and bad code? First, in my experience, I did it many times, pair programming and rotation. So I sit with Masha together, we work in the code, then I sit with Edward together, or Masha sits with Edward together, like we rotate all the time. So it kind of should solve the lack of code knowledge, and it kind of should solve the bad code problem, because if we're sitting together, Masha will spot my mistakes straight away if I'm just about to write them. Second option is ensemble or so-called mock programming, where it's not just I and Masha, but it's I and Masha and Edward, or I and Masha and Edward and someone else. The whole team writes the code for the problem, for the feature. Third solution I've tried a few times is where we have pair or mock session of design of the code. So we three sit together, agree on the skeleton, on the architecture, on the approaches within the code that we're gonna use, and then I leave them and I sit and work alone. I've tried it many times. It worked for me really well, and it's easier to sell to the managers. And the fourth one, of course, is solo work and code review. So for those two problems, if we are to follow empiricism, for those two problems, I can generate, maybe you can generate more solutions, but I can generate 4. Pair programming, mock programming, pair design, and code review. And in most of the teams which I join, I usually have code review, and I usually run this experiment. Oh yeah, there's another fun solution. I've actually heard it from one of the managers I worked for. He said that if we have developers emitting bugs, we should fire them. It was true. 2007. It was true. It was ridiculous. I quit.
You just need to fire one to encourage all the rest.
But it is,
The one who proposed it.
for the sake of this talk, I'm only considering 3 options, because considering 5 will take too much space on the screen. So the third step would be to generate a list of criteria, how we can compare. So we have those 3 options, these 3 options. How can we compare them? When we are comparing something, we always want to compare the cost, how much we're gonna pay for this. Either I'm using a hammer or some professional tool to do it. Depends on my context, which tool I use, but it also depends on the amount of money I have. If I have much money, more money, I can use some professional equipment. If I don't have, I can just do it with a hammer. Second is the speed. So if I'm building professionally something, I might be interested in speed, because if I'm like, I do leather craft. I love crafting stuff from leather, and it's my hobby. I don't care about the speed. I can be making one wallet for a week in the evenings, like half an hour this evening, 15 minutes this evening, and I don't care about it. But if I had manufacturing facility where I was producing leather craft, I would care a lot about speed. Otherwise, I wouldn't be able to satisfy clients. Third, of course, we should care about side effects. If you read about leathercraft, you'll be surprised how many people still die and suffer from the first stages of leather. It's not crafting. What's the word? Where are they?
Coloring?
Huh?
Coloring or?
Coloring. Yes, exactly. They use very strong chemicals. In some countries, they have very little protection from those chemicals. And so when
the Swedish word is garvning.
oh, yeah, okay, and so thank you. So yeah, people still are suffering from this, and this is a clear side effect.
Yeah, I think so.
I think we have another battery combined normal. Very hard.
No, and so we should care about side effects. As I've mentioned, with code reviews, a very common side effect is conflict. With pair programming, the very common side effect is burnout. Because I've learned it the hard way. I once tried to run the whole week in a pair programming way for at least 5 hours a day with a fellow developer. I was so burned out by the end of the week, because it's impossible. You're focusing too hard. It is a side effect. And then, as we have two definition of success, we need to compare how efficiently this practice that we use solves those problems. So we care about cost, we care about speed, we care about side effects, and the efficiency of the approach. So this is what I have. In blue is what I think I know. So I create a table. I join a team. I see they do a code review. I create a table with a cost. So I put it $1 per day, but I use the salary information, average salary of a developer. So if I'm paying a developer $1 per day, then solo work will cost $1 per day. It's just one developer working on it. I can average from Jira or from any other task tracker what's the speed of development for the features. So I can see that, let's say the team was really efficient, and it took average developer on average 3 working days to code the feature, and then 1 working day for the code review to happen, because you have to wait for someone to pick it up from you, to code review, to do the review, and then sometimes you have time to fix the issues that the person found. Then I know for sure that there is a side effect in code review conflicts. Then, in white, I hypothesize that knowledge sharing efficiency is 30%. It's like, I love this advertisement I've seen ages ago, where the shampoo was advertised, and the guy was saying that your hair will be 32% softer after this shampoo. Like, we can't even reason about percentage of softness, right? I mean, we can say, softer, okay, cool. But we can't say it's 32% softer. Of course, they can say we average some numbers, but with knowledge sharing, we can't put an exact number. But we can talk to developers. We can ask them, like I can ask Masha, you reviewed my code. How do you think you know the code? How well do you think you know the code? And she can say, well, I think I understood 1/3 of it. And we can get the data from Jira as well about the defects leakage. So we know for sure, I knew it for sure, I got it from Jira, that whenever I or anyone else on the team asks someone to review the code, QAs in half of the cases still find issues. Then I know for sure that if we are to try pair programming, we're going to be paying twice for the same feature, because it's 2 developers sitting. So we're paying $2 per day. And we can hypothesize, that's why it's white, that it's going to take 3 working days. So in the code review, in the solo work, it took developer 3 working days to build the feature and 1 working day for the code review. We can say that it won't take more for sure if we work together. It won't take 4 working days for us to build the feature, but we won't need code review, so it's 3 working days now. We hypothesize that there will be side effects of initial resistance. Not all developers know how to participate in pair sessions, and some developers might say, I don't like it. They will need persuasion.
Burnout too?
Of course, yeah, there is another known, yeah, for this example, I just took initial resistance. We also can hypothesize that knowledge sharing efficiency will be twice better, simply because we just sit together. We know the code we're writing together. And we can hypothesize that only in 10% of cases we will have defects leaked. Hypothesize, just an idea. And very similar to mob programming. So it's 5 people working together, so we're paying $5. We think we will be a bit faster, just because 5 of us. We think we will know, everyone on the team will know the code much better. And we think that pretty much all the defects will be found. Then we run the experiment. I think we should at least try empiricism in our work and be a little bit like Semmelweis. We don't have a good theory of knowledge sharing. Pedagogy is still so-called soft science, so it doesn't have exact numbers attached to every single theory. But we can try it out for ourselves. And some sciences, yeah, like maths or physics, it's considered hard science. We can say, okay, this is so efficient, this is not so efficient. Or chemistry, we put 1 gram of this, 2 grams of this, and we get so many grams of that. We still can reason about things which we can't fully measure, but we can talk to people. That's, again, going to be covered by Edward's talk later. So I couldn't persuade managers to try mob programming. I couldn't. Managers said, no, we ain't even trying that. But you can try pair programming for 4 weeks with a few pairs. I found those people who were not reluctant, who were actually eager to try it out. And we actually proved fairly that we paid twice the money, of course. But we found out that we were a bit faster. So if a solo developer, single developer, works for 3 days on a feature, together they work a bit faster. But again, as we don't have code review time, it's 4 working days compared to 2.5 working days. Then we found out, as you fairly said, that we were burned out much more than we had initial resistance. So that this was the problem. We couldn't work for 8 hours. So we could even factor that in here. So it's not even $2, it's 2.3. Because we can only work for 4 hours a day. And then we can do something else, like write tests or something else. We figured out that knowledge sharing efficiency was really, really higher. We said it was twice better. Again, it's only for us to reason about it. But we saw it in our experiment that whenever I and Masha, let's say, work on a code, and then we work on something else separately in a solo work, in solo method. Later on, if she is to touch the code, she knows it. Or I am to touch the code, I know it. So we knew that we improved knowledge sharing. We also found out that we weren't as good of QA as we thought we were, because still some issues were leaked to QA. But that, I think, is due to the fact that QAs must have a different mindset. Like developers are more synthesizing and QAs are more analyzing. So developers create and QA kind of think how to break it. And that's cool. That's cool because a developer is focused on the happy path, usually. We have the feature, user flow. We should first think about how it should work, and they think how it should not work.
Exactly. And there's no thinking.
And so,
How to break it off.
yes, exactly. And so, I have to remind myself with this. First definition of solution for the first problem was that developers don't get stuck, can easily work on any code. That was proved with pair programming to be much better. Definition of solution for problem 2, close to zero defects leaked, kind of proved. So for us to be able to decide between code reviews and solo work and pair programming, we had to answer this question. Are we ready to pay twice the price for a day for x 1.6 for 1.6 speed bump, so 2.5 working days against 4 days, and better problem solution? Are we ready to pay that? And if your managers say we're ready to pay for that, well, chances are you will have pair programming allowed for your team, simply because managers speak about money, and it's quite natural. And if we can talk the same language with them, we can persuade them to try out something which they wouldn't allow us to do before we brought the money language into the discussion. And of course, after we implemented pair programming in one of the teams, we had to review it later, because if time passes, maybe we aren't as tiresome as we were before with pair programming, or maybe conflicts arise, who knows, maybe something happened. So we need to make sure that our focused on empiricism experiment still is relevant to the current context, if it still works. So if the numbers that we put on the table are still consistent. I used retros for that. So whenever we implemented any practice, I reminded people about this practice on every single retro, and we discussed it. Like, are we still there? Are we still proving to the managers what we said we would prove? Are there any unplanned side effects? So for example, with pair programming, it turned out that we had much less of a side effect of people going on vacation, because people knew it better. People knew the code better. So if I'm working on a module, I'm not owning it anymore. Masha can work on it straight away. It wasn't a bad side effect, it was a good side effect for us. So this approach of defining the problem, defining the definition of solution for the problem, brainstorming the various solution, coming up with criteria table, comparing the solutions against the criteria and choosing one and experimenting on that, is the decision-making cycle based on empiricism. That's what Semmelweis did, and that's how science evolves until some scientists come up with a good theory. So and otherwise any decision would be a guess. How can I reason about what to choose, code review or pair programming, if I don't have any clue how to be able to choose between them? I don't have any criteria to choose. And we want better decisions at our work if we are focused on improving our quality and speed, so improving our competitive advantage. And managers want to talk about improving competitive advantage. And so if we want better decisions, we can't improve guesswork. We can only improve how we approach different decisions based on scientific method. Now, I had another interesting case where one lady on my team, she said that she kept failing at estimations. We had estimations at that team. So I forced every developer to estimate.
That's harsh.
Yeah, I forced them, it was 2010 I think, I forced every developer to estimate how much time it would take them to complete the feature. I built Gantt charts, ridiculous stuff. Sorry, and I built Gantt chart, and I presented this Gantt chart to my managers. So I was severely punished by other managers when the Gantt chart didn't come true. And of course I was punishing my direct reports, like whom else would I be punishing, right? And I forced her to guess harder. I told her, literally on a one-on-one, you have to guess harder. You have to think more how to estimate. And of course she did, she added 40% and all her estimations became true. But according to Peter principle, work expands to the deadline anyway. So it will expand to all the allocated time. And if we treat estimates as timelines, is it even reliable? Can we even rely on this guesswork to build project plans? I'm not sure, but can we apply scientific method here? I think we can. So the problem was for me, in my particular case, that it was hard for me to prioritize tasks. Why it was hard? Multiple product managers came to me and they said, Vitaly, a product manager responsible for retention came to me and said, I have this feature. A product manager responsible for acquisition of users came to me and said, I have this feature. So they had two features, and both of them had some idea what this feature would bring us. The retention guy said it would retain users for 13% better. That was his hypothesis. The acquisition guy said this would acquire 20% more users. So they asked me, what should we take first? What will you, Vitaly, your team, what will you take first? And the only way for me to prioritize between them was to ask developers for cost, for the estimate, how much time it would take you. So definition of solution for that problem would be if I had any other data to be able to prioritize tasks. And there are multiple solutions to this problem. There is a famous no estimates approach where the idea is that if two product managers come to me and ask to prioritize two tasks, I tell them, you go figure it yourself. I tell them, you have to agree what is of higher value to the company, 20% more acquisition or 12% better retention. So they prioritize based on value, and then I just build it. In some contexts it might work, but in some it might not. Then there is another one called statistical approach in Kanban. They approximate, they check the stats for the last 2 years, let's say. They approximate how much time it would take to build a feature. They say, on average, with some median, it takes us, let's say, 10 working days to build a feature with some prediction power. And they say, dear managers, you'll have your features in 10 days and 10 days. Of course, some features will take 20 days, some features will take 5 days, but on average is this. So this statistical approach can also give me data to prioritize tasks, because essentially it will be no estimates. I will tell them, just go figure for yourself. And again, if we are to compare multiple approaches for this problem, we should care for accuracy. If we ask developers to guess, what is the accuracy of their guesses? And also, how much margin do they add now? Because I, as a developer, I always added margins just to be on the safe side. And does it do any good to anyone? I'm not sure. I mean, I'm just adding margins just to be safe. It's not that I'm trying to be more accurate. So estimating doesn't bring good accuracy usually. And there are multiple studies in many companies where they say that developers' estimates are quite random usually. I can think that this feature will take me 3 days, and then I figure out I have to rewrite everything. It happened. And second one is cost. So for us to be able, if I'm a developer who really wants to provide a good estimate, a proper estimate, a high accuracy estimate, I must do some planning, I must do some experimenting, I must try proof of concepts, try something with this feature so that I reduce the amount of unknowns, I reduce the amount of information that I don't have. And the best estimate is when I complete the feature. So if I finish the feature, I can say, yeah, I mean, it's done. That's it. It took me so much time. If I spend, let's say, a couple of weeks for an estimation, I might turn out with a ready feature, with a completed feature during these 2 weeks. So
one question.
Yeah, sure.
When you ask your subordinates, why do you ask them for point estimates? Why don't you ask for a spread?
That period of time, I was asking for man days, for days. I wasn't asking for story points. With story points, the situation is even more interesting. There are multiple studies in various companies, again, that they do not correlate to man days. So you can't correlate story points with timelines. But again, maybe it's better in your company. But it is the cost of, we should consider the cost of the estimation process. If we want it highly accurate, we will invest a significant amount of effort into doing so. And the side effects, 40% or burnout, 40% margin or burnout. I've seen so many people burning out from deadlines. I mean, in my 23 years, I've seen people leaving companies simply because they were too tired of deadlines, most of which were set by themselves. They were giving the estimations, which is guesswork, which turns out to be a promise, because managers always treat your estimate as a promise. It will be delivered on Monday, that's the usual question. Will it be delivered on Monday? That's the usual question the managers ask. And if you provide an estimate, and if you're wrong, you're going to be working on Sunday and Saturday. So this is
it's better to give like what you think, and then also tell them like, well, it could take 2 days, but it could also take a year.
Yeah, but that's a good one. That's a good one, but will they accept it?
No.
I'm not sure. Because if the managers want to compare the cost, they want to get some accurate numbers on the cost. And estimations as timelines, as an approach, can be also reviewed from the scientific method. And I believe that scientific method, this empirical method, applies pretty much everywhere. We've reviewed code reviews versus pair programming versus mob programming. I once checked in one company the efficiency of postmortems, and we replaced them with Kaizen, which is a constant improvement. Because postmortems is a reactive approach to an incident. So something happens, you investigate the problem, you try to find a root cause, you try to blame someone anyway, because if someone committed a mistake which
I
led...
want to add to this one, because what you're trying to do with Kaizen to reduce waste.
Yeah. But with Kaizen, you're also improving everything. Because when you have postmortems, people can leave stuff hanging. People can leave bad stuff in the code. With Kaizen, the mindset is very different.
Yeah.
If you see something, you write a test and you fix it. You can also use scientific methods to compare sprints versus flow like in Kanban, where you take a feature after feature, and project approach. You can use scientific methods to think about if you need exploratory testing or not, how to actually implement it and how to experiment on that, or the TDD. Or one of the best ones for me, to compare manual testing versus automated testing, or the combination of both. Because we usually think that automation is good, but we just discussed with class that for some projects it might be not the case. If I'm building something for the 14th of February for the St. Valentine's Day, and today is the 10th of Feb, Do I need to automate everything? If it's just a landing page, I guess not. I'll just test it and I'll just throw it away after the 14th of Feb. And we can experiment on our current system with the combination or of both approaches or with just one. So if we don't follow the scientific method, magical thinking is the only option that we have.
Is it like a gut feeling?
Gut feeling, exactly. And gut feeling sometimes works really well, but
No.
sometimes it fails us. I've seen people who don't deploy on Fridays, or it's like, okay, but why? It is an approach. It is an approach for sure, because we're trying to reduce the risks of something happening on Saturday or Sunday. But maybe we should, instead of using this practice, maybe we should invest in CI/CD, in automated testing, so that we can deploy at any time, or in the reversion mechanism, where we deploy something and it's off and we revert it. Or when like magical thinking, another good example of it is when people use tarot cards or human design or something like astrology in hiring, and it is still a thing, unfortunately. I'm not sure why. Yeah.
I'm thinking that intuition is gut feeling.
Yes.
And intuition is usually based on
Stereotypes.
knowledge
Yeah.
from
Yes.
whatever you do.
Intuition is a very good tool which allowed us to evolve, like our species to evolve. When we see yellow stripes and black stripes, we think it's a tiger, because it's naturally for us. It's the threat. We'd better run, even if it's not tiger. We'd better run. Will it be bulletproof? Will it be always like working? Of course not. Maybe it's just some carpet there. But for us, it worked from the evolutionary standpoint. Now that we are into intelligent work, into engineering, we should validate our intuition, because sometimes it is biased, and biases might lead to inefficiencies.
It's like a tunnel vision.
Yes, exactly. It is tunnel vision of some sort. Yes. Also, a very popular thing that people copy approaches from certain companies. If they know that Spotify is successful, they study, they read the blog, and Spotify says, this is Spotify team model, it's so cool, and people think, oh, we need to steal it and we will be as efficient as Spotify is, even though the context is very different. It might not work at all. Or the famous one now about RTO, return to office. Big companies are inviting everyone back to the office, we need to. I've seen little startups, remote first startups doing that, opening offices because everyone else is doing that. It's like, wow, seriously, what's the rationale for that? And yeah, it's pretty much the same with code reviews. I believe that pretty much any practice that we inherit, we should question, because only then we can uncover some really inefficient pieces. One of the companies I know of, they published their data saying that 40% of lead time, so lead time is when you take the feature, developer takes the feature, and the feature hits the user. So this amount of time is lead time. Something is happening in this lead time, development, code reviews, etc. So out of lead time, 40% was eaten by code reviews. And they didn't even question it. Maybe if they questioned it, maybe it would turn out that code reviews were optimal for them. Cool, great. But if they don't question it, then maybe they are missing out on it. And yeah, we rationalize our guesses really well. We usually say, oh, let's say code review or estimations or hiring only men works for us really well because we always worked like that. Like those gentlemen, you know, with the Zemmelweis case. We always worked like that, it's great, it's cool. This is our rationalization. We explain it to ourselves. We don't want to be wrong, we want to be right all the time. And yeah, I reiterate, without a scientific method, any decision on implementing something or retaining something is just a guess, and we can't improve it. And scientific method can be applied to everything. And yeah, please don't believe it, try it for yourself.
I love your illustration.
Thank you. Thank you.